Thank you for being here. So I was transported here from the 20th century, and I am completely blown away by what has been achieved by this collaboration, VitaDAO and Bio and Molecule, in terms of the creation of this agent and this token. I've just been asked to speak for 10 minutes about really what the limitations are, the challenges that the longevity movement faces in, maximizing the speed with which we bring aging under comprehensive medical control, and the ways in which agents like Aubrai and the other work that you guys do can facilitate this and can make things happen faster. So I think I'm going to try and summarize this under three headings. Number one, siloing. Number two, funding. And number three, manpower. So with regard to siloing, what do I mean? Well, aging is this very chaotic process whereby the body damages itself in the course of its normal operation. And because the body is such a complicated machine, there are many, many ways in which that happens. And the ways in which we can control that damage are similarly diverse. So you have a huge variety of different types of expertise within the biomedical community, biomedical research community, that are being developed, usually for other reasons, to address this or that early onset disease, for example. And the people who are the world experts in these areas don't talk to each other very much. I have tried to address this quite energetically over the past 20 years or more by, organizing conferences, for example, that bring such people together when they would never normally talk to each other. But now we have this enormous opportunity with these bioagents to address that problem, to allow people to expand their areas of expertise and to interface with each other much more effectively than ever before, simply because it takes so much less time to gain that expertise, to understand why someone else's work is relevant, and also, of course, to do it in a creative way, to identify the right questions to be asking, to essentially have a dialogue with an agent that will lead one's own thinking in a direction that will facilitate the right kind of collaborations. And certainly my experience over the past 20 years or more has been that these collaborations and expansions of people's areas of expertise is enormously necessary, enormously productive in taking the field forward. So the next thing is funding. So, of course, there are many ways in which we try to bring money into this movement, and a lot of them are very unevenly distributed. In the private sector, anyone who wants to make money typically wants to make it tomorrow, and therefore there's an enormous bias in the private sector towards things that are low-hanging fruit, that can somehow address some aspect of aging, but that's not really where they're making their money. They'll make money in other ways, and so things get left out and neglected. It's the same in academia, where there's an enormous bias towards testing mechanistic hypotheses that get you nice papers in high-profile journals. Again, that turns out to be extremely biased towards certain aspects of the problem and against others. So that's why, over the years, I have led a succession of non-profit entities that are funded predominantly by philanthropy. This kind of sidesteps that issue and allows us to work on real moonshots, things that are longer term, but really necessary. And the work that we do at my current organization, LEV Foundation, is a great example of that. We are taking things that have been developed by other people and combining them in a search for things that combine additively to give a greater impact on delaying the health problems of late life. So, the thing about what AI agents and the AI token, Aubrey, can do here is enormous, because it brings people in to the field, especially people who think like engineers and who understand that aging is fundamentally a problem of preventative maintenance, which is something that, believe it or not, biologists have a really hard time getting their head around. But if you think that way, then you're already positively disposed to the idea that aging is something that we have a good chance of bringing under comprehensive medical control, but you don't have the expertise yourself to be involved at the bench, for example, the coin, the token, helps enormously here. You can do well by doing good. You can really, help us to do our experiments, but at the same time, you can be doing what you know how to do, working in crypto and profiting from it, doing things as you would with any other token. So I'm very, very happy about that. And the final thing is manpower. The key thing about the work that we do and the work that is done throughout the biomedical community is that a lot of it is extraordinarily labor intensive. If I give the example of simply keeping abreast of the literature, of the published literature, we have people in my organization that do that, but they can hardly keep up. In fact, they can't really keep up. Despite working incredibly hard. This can be enormously streamlined by an AI agent that surveys the literature and, of course, beyond the literature, including, for example, the patent literature and other areas, including the whole internet, and can bring things to our attention that would otherwise have been overlooked. And this applies, as I say, throughout the biomedical community. So it's an enormous value add. Another great example of this is the studies that we do, which are very large ones involving thousands of mice, which we're trying to make live longer. We have a huge amount of data that's generated, and actually analyzing that data and deriving new insights from it that may inform future experiments or even refine the current experiment. This is something that we hardly scratched the surface of in the past few years during the first study of this nature that we did. And now, in our subsequent studies, especially because we're going to be using what are called smart cages that generate data, minute by minute on these experiments, we will have vast quantities of data that we ourselves would have no prayer of being able to study. And now we're going to be able to make that data available to the wider community in a manner that can actually be analyzed with the help of agents like Aubrai. So this leads to better high-quality hypothesis formation as a kind of dialogue between the agents and the humans, and it's going to be completely transformational. I think I'm probably over my 10 minutes, so I'll stop there and hand over to Alex. You've got one.
Cool. Thank you so much, Aubrey. So yeah, I'm part of the VitaDAO team. I'm going to be talking a little bit about our vision for how we're using AI to fund and advance longevity science. So before I start, I just want to point you guys to this. This is essentially the terminal interface for the AI agent that we developed alongside Aubrey. It is Marco's going to run you guys through it in a bit with a demo, but this is essentially just prompting the agent and trying to create some hypotheses based on some scientific inputs. So that's coming next, but let me just walk you through the overall vision for what we're trying to do here. So VitaDAO's mission has always been to fund and advance longevity science, and we want to do this in a way that is much, much cheaper and much, much faster than traditional academia. So what we do is we leverage AI, crypto, and all of this tech to essentially get there much cheaper and much faster, right? So what we want to do is we want to have all of these agents being like a tool, like a co-scientist to many academics that we have as part of our community. So we want them to essentially be able to use this tool to create hypotheses first, and this is something that we're going to be talking in more detail here. The agent's actually pretty good at creating new novel scientific hypotheses already. So we want to enable this scientist that may have a crazy idea, that may not have a way to explore them or like means to explore them, and by means I mean either funding or like a team or connections necessary. So we want to have the agent serving them in that front. So hypothesis generation is the first one. But we want these AI agents to help them throughout the entire scientific process, right? So from hypothesis generation to experimental design, and then like data analysis, I think that's a big one. It's linked to the main power issue that Aubrey just brought up. So we want to have these agents capable of digesting visual data. So Aubrey's lab, for instance, is going to be generating a lot of visual data from the mice that we're going to be filming. So we want to have the agents tap into the data room and processing the data in real time. And then lastly, more further down the line, we want to have these agents also being capable of driving the scientists towards things like IP filing or commercialization, at least helping them to some extent in that front. And we want to have many of these agents deployed across the entire organization, and we want to have these agents, quote unquote, installed across many different labs. And the power of that is we have all these labs generating all this data. It's all proprietary. To some extent, we can obviously, it's open science, so we like to publish even bad results. That's like the core of the ethos of DeSci. But we want to have this data being used to further train the agent, right? So it creates this flywheel effect where the agent becomes smarter and smarter over time, given all of this data that it is consuming through the scientific research that we're developing internally. So at the end of this, I think we're going to have an agent that is really smart in doing science, and hopefully we can attract many different ideas. We have like very fast feedback loops from these ideas that might be too crazy to explore elsewhere. We learn from them, and then we create. Hopefully, we can create these moonshots over time. So I'll pause here. Marco is going to be giving you guys a quick demo over the agent itself and how it works. And yeah, hand it over to you.
Hello, I'm Marco. I'm from the Bio AI team. And yeah, I'll give you first a short explanation of how the technology behind the agent works, and then we can go through this demo that's kind of looping here right now. So yeah, Aubrey AI is an agent. It's supposed to be a digital twin of Dr. Aubrey de Grey. Yeah, the way it works is it has a bunch of tools. So I would first say about, I would first tell you about we call it the knowledge tool, and basically we fed this agent with a bunch of notes, unpublished research, yeah, basically a lot of things that the LUV Foundation gave us. And yeah, the agent, whenever it's prompted to do something, because obviously it's supposed to be a digital twin of Aubrey de Grey, it's supposed to behave and think like him. That's why it always queries those nodes. And we also trained like a voice model, so we don't have voice right now on the presentation, but like it can also speak like Aubrey, and we have like basically a character file which makes it kind of behave like him as well. Additionally, we have 4,000 size papers that we query in two ways. So one of the ways is a model that's called Open Scholar. So Open Scholar is already a fine-tuned model for science papers. It's basically like trained on general papers, but we further fine-tuned it by taking these 4,000 papers, which 2,000 of them were provided by the LUV Foundation, and another 2,000 we have a tool in VitaDAO which is used to grade papers. So we took a bunch of longevity papers, like 10,000 of them, and graded them, and we took the top 2,000. So we further like cleaned these 4,000 papers, we transformed them into like very structured data, and we used it to train this model, and now it's using, well, basically a re-ranker and a retriever. And each time that a question is related to, obviously, science, it uses this tool and essentially retrieves semantically similar parts of the papers which are related to the question. So if you ask about, for example, here, I think we mentioned like mitochondrial uncoupling proteins, it's gonna look for papers that mention it and take sections from them which are related to this. We query these science papers in another way, actually, and that is the knowledge graph. So the difference essentially between just querying papers in text versus querying a knowledge graph is that this graph represents relationships much better. So in the graph, you can obviously see like each paper is described by, well, not only one node, but a bunch of nodes in the graph. And essentially, if a paper talks about the Alzheimer's disease, it's connected to that node. And all of the other papers that talk about the Alzheimer's disease are also connected to that node. And each time you query it about science, we traverse this graph in some way. And that's how we additionally get valuable insights from these papers. Yeah, so this agent runs both on the terminal and on Twitter. The idea is like you can obviously try it on Twitter, but also here, like we have an invite code for all of you, so it's Aubrey.ai. I don't know if it's, so AUBR.ai. You can use the code bioprotocol, so everything together, bioprotocol. Yeah, so I wanted to run you through this demo as well, but I guess it's looping right now, so I'm gonna wait a second until it does. But like Alex said, there are really quick loops in which you can find your science here. So essentially through this demo, I'm gonna show you how we went through, well, obviously it's kind of a demo, but like you could, in theory, in one conversation, have some idea, have the agent enhance it, and then essentially mint an IP NFT which represents this data. You wanna, yeah.
I just waiting in real quick. He's gonna walk you guys through the process of minting an IP NFT. I just want to quickly give you guys an overview of what that is and what that represents. So you can see here, first there's a research processing, that's the iterative process for creating a hypothesis. And POI stands for proof of invention. So this is essentially a proof that you, the scientist, own that idea. So that is essentially an NFT on-chain that only you own, so you can prove ownership over that for anyone. And then the IP NFT is basically the next step to develop that POI. Essentially, usually there is a sponsor research agreement attached to or underpinning that IP NFT, which essentially represents, the terms under which you're going to be developing that idea. And usually there is a funder behind that IP NFT. In many cases, the funder is VitaDAO. So VitaDAO has funded, I think, more than 20 IP NFT projects so far. This is the process. Well, I don't know if that's the right timing to be there in the presentation still, but we're going to walk you through essentially the capabilities of Aubrey to enable anyone to kickstart a project, that process really, really simply. So you interface with it, you bounce ideas through it, and then you come to a point where your hypothesis is worth exploring. You can essentially mint your POI and develop your idea from there.
Right, yeah. So here I asked some, well, it's not really a simple question, but I asked some question about science, about whether tuning mitochondrial energy flow and cellular NAD+ levels restore youthful metabolic flexibility. Actually, this is someone from our community which posted this on Twitter. We're just mimicking it here. Based on this example, so I explained the flow, how the agent works in theory, but considering this question, so the agent is going to see these questions, is going to think, okay, how am I going to give the best answer to this question? First is going to query Aubrey's notes for potentially if he has any opinions on this. And let's say, we could say that's kind of subjective, because obviously we do want this agent to be as close to Aubrey de Grey as possible. And then it's going to also query this model that we trained on the science papers and the knowledge graph to, let's say, retrieve some insights from other papers which are potentially not related to Aubrey de Grey. And it's going to take both of those inputs, and it's going to give you the final answer. And that's why we're trying to, this agent basically should be as close as possible as to you, literally doing research with Aubrey de Grey, but obviously this is an AI, it's not a real person. But unlike Aubrey de Grey, it's available 24/7, and you can constantly talk to it and further refine your hypothesis. And yeah, here I asked it basically based on its answer to create a hypothesis, and also to give us some information on how we can test this. So in theory, after this is done, yeah, so it's going to give us a hypothesis. And you can, like Alex said, first mint a proof of invention. So proof of invention, I think Kevin is going to give a talk about it later. But in short, this whole conversation is taken, it's hashed, and it's stored on the blockchain, which is basically proof that you were the one who actually created this research along with the agent. And yeah, once that is hashed, you can also additionally create an IP NFT, which represents this research, and later also create an IP token, which could potentially raise funds to fund this testing of this basically hypothesis, this experiment, because obviously that's also not cheap. Yeah, I don't know how we are with time, but I think that's pretty much it regarding the demo. We can open for questions or just talk in general more or something. Yeah.
Q&A. If anyone has questions, we're here to take them.
Any questions? Do you guys have a launchpad or whatnot set up for after token generation, and what like fee cut of inventions or whatnot do you guys take?
So the launchpad that we're currently using is BIOS. So Aubrey itself was launched through the Bio Launchpad. Some of these ideas are also going to be launched through Bio Launchpad. Some of them coming really, really soon, actually. So yeah, that's currently how we're using it. And you asked about the fees. So usually what we do, and that was the new model that we implemented with Aubrey, is we not only crowdfund through the sale itself, we also crowdfund through trading fees over time. And that is an interesting model because it can create this perpetual funding for the research project, right? So in the case of Aubrey, for instance, we launched a token through the Launchpad, but we have generated more fees through trading fees than with the launch itself. So they need funding for the next 48 months, so we can create that funding over time through these trading fees. So that's more or less the model.
What DEX does it get integrated in?
Well, all the Aubrey is launched on Base, so we are basically on Airdrop and Uniswap. But we are expanding to other chains as well.
The proof of inventions, do they get like a can they be patented? I don't assume that they're built in.
The proof of inventions are not patent. They're not patent. They're just ideas. So they're like the very first step in the process, right? So the IPNFT and the IPTs are more robust or more like well-developed ideas. So those can be patented as we go further down the funnel.
Cool. I've got another question over here. Give me a second.
Hey, thank you for the presentations. Very interesting. A question from me. So you answered a bit about the business model of basically how you, in long term, you will get funded. So the product, if the product is LLM or ChatGPT for scientists, and the second question is, what would be the next step after longevity? Do you have other like fields that you would be interested in? Training an LLM?
Okay, so I'll take the second question first. Well, VitaDAO is a longevity-focused community. So from our side, we only do longevity. But other bio agents are launching through the Bio Launchpad. I think Paul's going to give a talk in a little bit, talk about them. There was recently we launched the Bio Biome DAO. And there are other coming, so longevity was the first one, but there are others through the Bio Launchpads coming soon. But from our side, Vita, we only do longevity research. And your first question again, apologies?
So it was about the business model. So I guess that the cost also would be, if you train your model on a lot of scientific paper, you have to pay the access to the scientific papers, I guess. So you have to pay fees probably, and you will like recurring fees. And so the question is, how do we get, what is the long-term, I would say, business model, and who is going to pay and how much?
Yeah, I think that's a link to my previous answer. Aubrey is a token on trading on the blockchain, and there is a fee that is actually baked into the smart contract of the token. So every time that someone is trading the token on DEXs, part of that transaction flows back into the treasury of the agent. And then the treasury of the agent can be used to cover expenses like access to, token gated, access to research papers and all that.
Thank you.
Cool. We have time for one more question. Going? Gone. Cool. Thank you so much, guys. It was great having all three of you on stage.